Okay, here's number 49, section 5.5, some more trig equations. And first of all, we'll just isolate this, so we'll just say that we'll add 3 to both sides, so we'll say 9 tangent squared x equals 3. Then we can divide both sides by 9. So the tangent square root of x equals 3 divided by 9, which is equal to 1/3. And then we can take the square root of both sides, so the tangent of x equals plus or minus the square root of 1/3, which is plus or minus 1 over the square root of 3. Alright, and that should pretty much look like pi over 6. The tangent of the square root of 3 is pi over 6. So x would equal pi over 6. Well, x, let's say x, I guess I shouldn't skip that step. So I'll just say down there that we know that the tangent of x equals 1 over the square root of 3, or the tangent of x equals negative 1 over the square root of 3. Alrighty. And now we know the tangent of x equals 1 over the square root of 3 when x is equal to what? Pi over 6. But it's also positive, so it's going to be also in the third quadrant, which would be 7 pi over 6. And then we know over here, x equals negative, the tangent, just when the tangent is negative, that's going to be the second and the fourth quadrant. So that's going to be good old 5 pi over 6. That gets us in the second quadrant, and the fourth quadrant is the 11 pi over 6. So those are your 4 possibilities. Okay? So basically pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. So that covers everything. Okay? Number 51. See if I can get that over here, save a little space here. So we'll do 51 over here. And that's going to be the secant squared of x minus 2 equals 0. So first of all, we'll just add 2 to both sides, so you get the secant squared of x equals 2. And the secant, that's going to be 1 over the cosine, so I'm going to rewrite that. Just 1 over cosine squared of x, that's the secant squared, equals 2. And then what I'll do is I'll put this on top and that on the bottom, so I'll just multiply both sides by the cosine squared and then divide by 2, so I end up with 1 over 2 equals the cosine squared of x. You can do that. And then if I take the square root of both sides, I get cosine of x equals plus or minus the square root of 1/2. And then I can break that up. And that's plus or minus 1 over the square root of 2. Then I can multiply the top and the bottom by the square root of 2 to rationalize that. So I get the cosine of x equals plus or minus the square root of 2 over 2. So I got a couple possibilities, okay? Cosine of x equals the square root of 2 over 2. I think we know what that is. And the cosine of x equals negative the square root of 2 over 2. Alright, that's an or there. So so x equals, and we know it equals the square root of 2 over 2 at pi over 4. So x equals either pi over 4. But it's also positive in the fourth quadrant. So that's going to be 7 pi over 4. Okay, remember your quadrants. Remember how to kind of figure those out. Okay, and then the cosine will equal negative, so x is going to be in where the cosine is negative, and the cosine is negative in the second and the third quadrant. So that's going to be 3 pi over 4 and 5 pi over 4. That gets us in the second and the third quadrant. So you got all, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. That covers all of them. This is your first and fourth quadrant where it's positive, your second and third where it's negative. Okay? So that's not too bad in 51. Okay, take a look at 52. I'm sorry, not 52, but 53. Pardon me, 53. Okay, and then these are all factors. It says solve each equation. So we're still in the interval 0 to 2 pi. Okay, but we want to solve each equation, but well, they factored them for us, so that was kind of nice. So we've got the tangent of x minus 1 times the cosine of x plus 1 equals 0. So we can just set each factor equal to 0. So the tangent of x minus 1 equals 0, or the cosine of x plus 1 equals 0. So we got those two possibilities. And here if I add 1, I get the tangent of x equals 1, or the cosine of x equals negative 1. Now tangent of x equals 1 at pi over 4, but it's also positive, so x can either equal pi over 4, or that's also positive in the third quadrant, so that would be 5 pi over 4. Okay? And then the cosine of x equals negative 1, x equals, now remember on that same interval, so where did my cosine graph go? Here's my cosine graph, remember that one? And it equals negative 1 at pi on that interval. So those are your answers. Okay, see if we can get one more in here. So this would be 55. So here's 55. 5.5 homework. Okay, so 55. Okay, 2 cosine of x plus the square root of 3. And that's going to be times 2 sine of x plus 1. And that equals 0, so we just set each factor equal to 0. So we've got 2 cosine of x plus the square root of 3 equals 0, or 2 sine of x plus 1 equals 0. So they shouldn't be too bad. Then we just solve for the cosine of x. So the cosine of x equals, if I subtract the square root of 3 from both sides and then divide by 2, that's what I've got. Subtract 1 from both sides and divide by 2. And then that should be easy to figure out. It looks like that's going to be pi over 6, but pi over 6 for the square root of 3 over 2. The cosine of pi over 6 is square root of 3 over 2, but we got negative, so it's going to put us in the second and the third quadrant is when the cosine is negative. It's positive in the fourth quadrant and the first. It's not going to be pi over 6. It's going to be 5 pi over 6 in the second quadrant and 7 pi over 6 in the third quadrant. Okay, the sine of x equals negative 1/2. So the sine equals, that's pi over 6, isn't it? Sure is. Sine of pi over 6 is 1/2, but we're going to be in which quadrant? Well, we're going to be in the, it's positive in the first and second quadrant, so we're going to be in the third and fourth quadrant. So the third quadrant is 7 pi over 6 and 11 pi over 6. So it's 5 pi over 6, 7 pi over 6, and 11 pi over 6. So these are kind of overlapping. So your solution set would just have these three angles. You wouldn't write that twice. Okay. All right, so that's, like I said, if you're going to write your solution set like this, it would be 5 pi over 6, 7 pi over 6. We don't need that. We already got that in 11 pi over 6. Just want to be formal about it, that that's your solution set. Okay? Hope that helps.